Hello everyone, my name is Arash Khatibi and today I'm going to give you a short tutorial about a simulation software which is really well known in designing and simulation of renewable energy systems, especially. You can say also in general for all energy systems like the normal grids or also the conventional energy systems. And this program is called HOMER, and this version that I'm going to show you is HOMER Pro microgrid analysis tool. It is written also above this window, and this is the version 3.13. I guess, no, I'm sure that this is the latest version of this software. As you've also seen in the lecture slides, you can also download this program freely from their website, homerenergy.com, and you can register your account with an email address, and it will work for 3 weeks just completely freely as a trial version, and all the components are also available in the trial version. So I'm going to ask you to download this software for sure and try it at home, and then try to play with it a bit at home, and then just make yourself familiar with it, which is really interesting and gives you a great idea of how to design and simulate energy systems. So as I said, the trial version is free for 3 weeks, and then afterwards you need to pay for the software, but of course it's a really expensive software. You don't need to buy it, of course, but try to make yourself familiar in the trial version. Okay, so as I said, this HOMER Energy company has different softwares as well, but we are going to talk about HOMER Pro, and this is the first page of the software when it is opened. You may see here that we have a toolbar here, of course. We have some comment area about this, that the program gives you some proposal or suggestions on how to improve your project, for example. And then we have the main area of the project, and then here is the map of the world. So you can search for the location, for example, that your project is going to be installed, or your system is going to be installed, or you can give the geographical coordinates of the location in this area, and then it will find it for you. Or as I said, yeah, you can also scroll into the map like what I'm doing right now, and then find your place and just choose that location. This is the first step, for example, in this part. Yeah, and then for example, here is the area that you can put a name for your project, and then the author of the project, and you can also write some description of the project, and there are some basic parameters in the beginning that you can add, like the discount rate or inflation rate of the installation country, for example. Afterwards, for example, another parameter, annual capacity shortage in percentage. This parameter is defined like the how many percentage of electricity can be shorted during a year. So it means that you say that, okay, I want to have a renewable energy system with only, for example, photovoltaic modules, and I am allowed to have 10% of shortage, for example, during the whole year, which is a really high number, but just as an example. Or usually you say that, okay, I don't want any capacity shortage, so this number should stay at 0%. And then another parameter is the project lifetime, which you say that, okay, my project is going to work for 25 years, and then it shows you the financial and all the other costs of the project during this lifetime. So, as I said, there's a toolbar here. You can find the first tab is Home, which wherever we are, it brings us back to this page. So, for example, if I'm in the result page, Home will just guide me through the first page one more time. Design page is showing the design of our system, but so far we don't have any implemented system already, so there's nothing else here. Results page, of course, will guide us to the results page after running the simulation. And then there is this library that goes into the library of HOMER Pro software, which is needed sometimes when we are talking about different definitions or parameters, or maybe we want to know more about how a calculation is being done in the background. So it just shows us some formulas about it and then said that, okay, the program is calculating that parameter through these calculations. Later you see also various toolbars here like load, components, resources, project, and help. Now first I'm going to start talking about the load. In load tab you can see electric load number 1, electric load number 2, and a deferrable load. These other components which are blanked out, it means that they are not available in this version that I am having on my computer. But when you have the trial version, as I said, all the components will be available for you for 3 weeks. And then depending on what version you will buy afterwards, some of these components will be available and some will be not available. Like for example, let me just go to the components tab, and you see that some boiler, hydro energy, and electrolyzer or something, they are not available in this version that I have. But the most of the components that we need for renewable energy systems is available, and I'm going to show you about those. Okay, so I was talking about the load, and then the first one is electric load number 1. We can add more than one, like electric load number 2. We can even add much more. And then we also can have a deferrable load, which means that we can edit the load however that we as the user want. Okay, so this is the page for electric load number 1. This part is about the introduction of the other softwares of the HOMER Energy company. Or you can say that it's just the advertisement sometimes. And okay, so the first part that we are going to see is this rectangle here. There are some default loads or default load profiles which are already implemented in HOMER. And if you want to just run a quick and just short simulation, we can just choose one of them. It's easy. It is already, as I said, implemented. All the numbers are already inside, and then we don't need to enter any load amount into the program first. So for example, in the first one, we can say that which month is the peak month of the load during the year. So usually with countries in northern hemisphere, the load profile will be much higher in January. It means that the demand is much higher in January or in winter time. And then for the countries which are in the southern hemisphere, their load demand is also higher at their winter times, which is our summer times, for example in Germany, which is July. So I'm going to just choose January for Germany that we are looking at it now, and then I'm going to choose one residential load. We can also choose commercial, industrial, community, or a blank load, which we can enter all the load amounts on our own. I'm just choosing residential right now, and then I will click on OK. So now the page is changed to this page with different diagrams. Okay, so let's start. We can say that we can edit the name of this electric load. We can just consider it as house number 1 or factory number 1 or something like that, or even just a small load like, for example, the refrigerator, and then we put the numbers for usage of a refrigerator during the day. So this is the hourly distribution of the load. For example, for this residential load that is entered by default in HOMER, you can say that, okay, in January, in the hours from midnight to 11 o'clock at night, these are the different various numbers of the load in kilowatt. So if you take a look at the numbers, you can see that, okay, it's starting slightly low number around 100 watt, and then it goes higher in the beginning of the morning, and then goes a bit lower, and then around 11-12 o'clock until, yeah, you can say 13 o'clock, which is high demand around these hours, and then afterwards it goes down again, and also again in the evening it goes higher to the maximum number of around 1477 watt or 1.4 kilowatt, and then again it goes back to the minimum number of the day. These numbers are drawn here in this diagram. So the horizontal axis is about the hours of a day, and then the vertical one is the amount of load in watt or kilowatt here. So these are the numbers exactly. The first one is 130, and then 110, and then it goes higher, as I said, in the beginning of the day, and then it goes down again, and then also in the middle of the day it goes again high a bit, and then goes down, and then as we expect in the evening, which is the most demanding time, we have the maximum load here. Okay, so now if I click on this button, show all month, I can also see the details for every hour of the whole year. Like for example in January, yeah, they can say that in all days this is the load profile. So in all days in January at 9 o'clock we have 500 watt of demand, like this. It's just simplified like that. And also in February, all days of February, but it is a different number than January, and you can see and just take a look at it until December, and you can also edit each of them if you want, and you can also copy these numbers to the right and to the left, or like weekends or something like this. You can, as I said, even change the load demand in weekends and weekdays, and even just make it different for every month. Yeah, if you play more with the software, you can also find ways to add exactly hourly load profiles into the programs, and then not consider all the January days as they have the same load profile. You can also change them for every single day, but in this case we don't need to do that. We are just looking at an example here. So okay, that was the electric load, and then with this button show all months you can check all the load profiles in the months, in different months of the year. So, and then you can see a seasonal profile of it, with this kind of diagram which shows the median, maximum, minimum, and then also the average of that load in different months of the year. And this one is the yearly profile of our electric load, which shows you this, like this is the first day of the year, and then the final number on the horizontal axis is the last day of the year or final day of the year, and the vertical axis is also the hours of the day from 0 to 24. You can take a look at all the numbers and all the dates and all the hours in this diagram. So you see that, okay, the beginning of this, when we go vertically on this diagram, the beginning of the beginning hours of the day is during the midnight, and then of course it goes to middle of the day, and then it goes to evening. So as we expect, around 6 o'clock in the evening until 8 o'clock or 9 o'clock is the maximum demand for the electricity. And then you can see that also in the middle of the day it's also a bit higher, and also in the beginning of the day. But in between the colors are dark blue, which are less than 500 watt, for example. Okay, so as I said, if I keep my mouse here at this point, it means that it shows that it is 25th of July and 2007, which is like an example. I guess this load was taken from a specific date, and then it also shows the value of that load, which is, for example, in this point it is 660 watt. Okay, so here we have also some parameters, which is the average of the load in kilowatt hours per day, which for this residential load, which is around 11.25 kilowatt hours per day, and the average load is during the whole year is 0.47 kilowatt or 470 watt. The peak was this number. I don't know, it happened maybe around these points in red in this diagram, or also here. We have also another parameter like load factor, but we don't care about it right now. And if you want to add an efficiency to the for example, our load, you can also add it here. If you want to say that, okay, we have also this amount of loss, energy loss with this load, you can also add it with this point. And then with clicking on this button plot, you can take a look at various diagrams of the load. Yeah, you can add different diagrams here, and then you can take a look at them. But let's go to monthly. As I said, this is the monthly, which we've seen already here. And then we go to the profile. So this is how our load profile looks for every single month of the year. So January is looking like this, and then, for example, in November is a bit higher in this amount, or it doesn't look that way, but at least it's a sharp peak here. And in the summer times, where is it? Yeah, like August or July, you can see the numbers are a bit lower. And yeah, that's it. So you can, as I said, take a look at the diagrams for each month as well. If you go to DMAP, you can just follow the numbers again, like what we had here for the yearly profile. And then you can also take a look at the histogram diagram of it. And then like the horizontal axis is the scale data in kilowatt, and then the frequency is on vertical axis. So you can say that the load demand of a bit less than 500 watt is the highest, or the most frequent load demand, which is around 17%. That was for the load. Other parts you can also play with the software yourselves and then find more about those. So I'm going to show you the next part in components, the next tool bar, so which is components, and then you can add or edit or modify different components of the project to the system from this point. You can add a controller, you can add a generator like diesel generator or all conventional generators to the system. You can add a photovoltaic module or a photovoltaic module systems with all strings and whatever. And then you can also add wind turbines, and then storage systems with different type of storage like battery and other types of the batteries, or a storage system like flywheels. Sorry, let me just take a look at this part later. And then you can also add a converter or inverter to the system, and if you want, at the end you can add a grid to the system, which this version that I have. As I said, some other components like hydrogen tank or electrolyzer is not available in this version, but we also don't need to talk about them right now. Let's click on generator and then show what's happening here. So You can choose some options for a generator from this tab, and then you can see that, yeah, generic 10 kilowatt fixed capacity generator set, or generic 50 kilowatt. It means that these generators, they are not specifically defined like with a brand and with a model. It's just generic ones with a capacity. And then you can see also that here, for example, fuel cell is also available here. But if you want to choose one generator with its specific brand and model, you can click on this complete catalog button, and then you can find many available generators in this area. You can also take a look at the manufacturer parts. For example, in this case it's Caterpillar in some of them, and then GE, General Electric, and then a lot of other manufacturers. But you can also add whatever that you want in between. You can also define generator on your own as well. Okay, so I'm just going to click on, for example, a generic 50 kilowatt generator, and then I'm going to click on add generator. So now this will be added, and then I can see the other parameters of the generator here. So here you can see the different characteristics of the generator. This is a diesel generator with the capacity of 50 kilowatt and fuel curve intercept of 1.65 liters of fuel per hour and fuel curve slope of 273 liters per hour per kilowatt. You can also take a look at the emission amount of this generator here, and then the fuel properties and whatever that is written. So you can also, in this area, you can add the price, the buying price of this generator first, and then you can also add the replacement cost of it. So for example, after 10 years you want to change it, so if you need to pay the exact same amount, or no, you need to consider more. And operation and maintenance of the device can also be added here, and the unit for it is already in dollar per operating hour, and for example in this one is $1.50 for 1 hour of operation. And then you can also add the fuel price, in this case the diesel price, to the system with the unit of dollar per liter, which is now already is by default on $1. So yeah, what else I can show you here? The other ones is just the normal stuff. You can choose that if this generator is producing in AC or in DC. So let's see if it is on AC. Let's take a look at this schematic diagram here, which is generator is connected to our AC bus bar, which is connected to our electric load, which is also an AC load. But if I choose DC here, it shows that generator is providing to a DC line, and then our load is also AC, so we need to think about some inverter or converter in between. But as I said, if I click on AC and keep it that way, so there's no need for a converter. There's also one option here that you can say that I want to simulate systems with and without this generator. So if we say that I have a PV generator as well, so you also want to take a look at the systems without this generator, or you want to say that, okay, I want to know that all our systems, all other scenarios also include some generator. So you need to click on this one, choose the right option. Yeah, you can also keep on clicking advanced here, advanced button here, and it goes to much more options here, but I don't want to talk about too long for this part. So let's go to the next one, which is the PV generator. So I'm going to just keep this generator, for example, until later, and then I'm going to click on PV. So yeah, This is the exact same idea as generator. You can choose the main type of the generator or photovoltaic modules, like generic flat plate PV, concentrating PV, or another type, variotrack, for example. But yeah, generic flat plate PV is what we need right now. As I said, you can also click on complete catalog here and then take a look at different manufacturers and choose one of those companies like Schneider Electric, SMA, Sharp. Yeah, there are many known companies. Huawei, sometimes QCell, which is a very well-known company for producing solar panels. So you can also choose one of those, or just consider a generic one. If you click and then choose this generic flat plate PV, after the simulation, the program will suggest you only the capacity of the PV needed for the system, and it doesn't suggest you any brand or any photovoltaic modules with good or bad efficiencies or whatever. It just shows the capacity that you need. So I'm going to click on add PV, so you can see again a new page is opening up, and then you can see that the capital cost of it is, for example, $2,500 for every kilowatt. You can change this number. You can say that, okay, I want modules which are, I don't know, $200, for example, for 200 watt or something like that, and then choose it accordingly. And then if you want to change it after its lifetime, you need to click on this area and then put the cost for replacement and the operation and maintenance costs, and then also the lifetime of it. You can say that 25 years. I'm sure that my PV is working fine. And also you can change the derating factor of the PV modules. It means that if the output of the module is 80% of its nominal capacity, so it is considered as a derated PV module, and then you need to replace it. So yeah, you can also choose AC or DC electrical bus here, but yeah, we just keep it on DC. Of course, the PV modules are producing in DC. So yeah, let's see if I click on advanced. Yeah, there are some other parameters that I can enter, like model a maximum power point tracker as well in between. I can say that, okay, yes, model an MPPT with a lifetime of 15 years and the size of it. And I also can choose an efficiency table for the maximum power point tracker. For example, by default is 95%, but okay, let's put it out for now. Then the orientation of our PV module. Yeah, ground reflectance of the area, you need to know it based on the location that you're going to install the PV modules. For example, by default is 20%. It meaning the same as the albedo amount. And you can also choose the tracking system if you have any for this PV module. You can say that, okay, I want to track it on a horizontal axis and I want to adjust it monthly, weekly, or daily, or vertical axis even, and then also in 2 axes if you want. Yeah, there are 2 ticks here. You can just check one of these check marks or even both of them. The first one is about use default slope. So depending on the location, HOMER suggests you a panel slope, and then you can keep that as well, or if you're obliged to keep, for example, a slope for your PV modules, you can also choose here and then say that, okay, I want to have it in 30 degrees, for example. And also the azimuth. Again, default azimuth means that the HOMER energy software will suggest you the default azimuth, or you can say that, no, I want to install my photovoltaic modules only to the south or to the north or something like that, and then you need to enter the azimuth angle here. Next one is the temperature. If you want to consider temperature effects, yeah, you just click it on, And then you can say that, okay, I want to have temperature effects on power with this percentage per centigrade, which is, for example, in this case by default is minus 0.5% per Celsius. And you also need to enter nominal operating cell temperature of the module. And if you want, you can also add the efficiency of the module here, or even change it. And of course the efficiency must be in STC or standard test conditions. So for this part, so I'm going to go to the next component. Next one is the wind turbine. This is exactly the same explanations. You can choose the generic ones here and more specific ones here with different brands like Enercon, other ones. And I'm going to keep this generic wind turbine with 3 kilowatt of nominal output. So when you add it, you can see again different parameters which we can decide on our own, like the capital cost of it, replacement cost, operation and maintenance cost, and then the lifetime of it, which is by default 20 years, but we can change it, of course, and the hub height. We can also say that we just change it to another height. Now by default it is set on 17 meters. And you can also say that I want to consider ambient temperature effects or not on this wind turbine. If I click on advanced, I can see that I have a power curve for this generic wind turbine. This is the power curve. It means that it shows the power output of this type of turbine depending on the wind speed of that location, or at the same, in what specific hour. And then you can see another tab here as turbine losses. You can enter other losses here if you want, and like a maintenance table if you want. You can say that I want to do some maintenance every year or every 6 months or whatever that you want, and then the program will simulate your system based on that schedule. And then it shows also the costs. It also considers the costs of operation and maintenance for that matter. Okay, the next part I'm going to show you the storage. Again, exactly the explanation is the same. You can choose the generic battery systems. For example, this first one is lithium ion, the second one is lead acid. You can also take a look at other storage systems like flywheels, and different types. And then if you click on a complete catalog, you can see a lot of battery systems or other type of storage systems. Okay, so like flywheel, for example, here. I'm going to keep my selection on generic 1 kilowatt hours lead acid battery. Lead acid batteries are the standard in renewable energy systems, considering PV energy especially. And but you can of course consider lithium ions, which have their own advantages and also disadvantages. Okay, so I have added one lead acid battery. You can again enter the capital cost, replacement cost, operation and maintenance, lifetime of it. This is 10 years for example for now. And if you want to say that okay, my system is going to be 12 volts, so you need to just say one string. If you add 2 strings, it will be changed to 24 volts. You can even choose your system voltage here. Initial state of charge is 100%, which means that when we buy this battery or when we want to start our simulation, we consider this battery as fully charged. And minimum state of charge is another part that you can say that I want to keep the depth of discharge of this battery to around maximum 60%, which means that the battery will be only discharged until 40% of energy is still remaining in that battery, and it is of course important for the health of the battery. Okay, so yeah, that was for the storage system. Next part is the converter. If I want to add a converter as a component of the system, I can also add it here. For example, as I said, we can see that our load is in AC. Yeah, wind turbines produce also in AC, generator is in AC, but photovoltaic and our battery, of course, they are in DC, so we need a converter in between. So I will click on converter, and then you can see that the converter is added between DC and AC bus. I can even again change the costs for the converter here, and their lifetime as well, and also the efficiency. For example, the efficiency of the inverter could be changed here. It's 95% by default. Also the rectifier, which is other way around. I mean, it is AC to DC, so that's also can be implemented here, the efficiency of this rectifier as well. Okay, so this was about the converter. Now I'm going to continue to grid here, hydrokinetic energy. We don't want to go inside that right now, just for our example. Let's go to grid. Yeah, if we want to say that our system is on grid and it's not off grid, it is connected to the grid, and then if we lack enough renewable energy, we can have it from our grid, or even if we have extra energy, extra produced energy from our renewable ones, we want to sell it back to the grid, so we need to add this component from this toolbar. So you can say that, yeah, grid power price is, for example, 10 cents per kilowatt hours, and the sell back price is 5 cents. It means that if we need more energy from the grid, we need to buy it for 10 cents, and if we want to sell our extra energy to the grid, we will be paid only 5 cents per kilowatt hours. These are the numbers that can be modified for depending to the location site and the regulations of the country. And about the net metering, we can also choose this part. You know that we have feed-in tariffs and net metering. Net metering systems, they have only one electricity counter, which considers the production and extra needed energy from the grid, and then it just gives you the result, the final result of energy which is produced and is fed to the grid, or it is bought from the grid. But if we consider feed-in tariffs, in feed-in tariffs we have two counters, electricity counters, and then these two counters, they count the amount of energy which is taken from the grid, and the other one is counting the amount of electricity which is fed to the grid from our renewable system. But this is depending on the locations. Let's just leave it like that. Okay, next tab is about the resources. I'm going to click on the resources. So I can enter my resources data in these area. Like I want to say that I have this amount of potential solar energy in this area, how much is the average irradiance level for each month, or how much is the wind speed during the whole year, or how much are the average temperature of the of this location through the whole year. So these are the basic data that we need to start designing our system based on them. So yeah, but these are of course depending on the location of the installation site. So for example, I need to go back to home for this matter right now. I'm going to click on home. Now the location, installation location is clicked on middle of the ocean here, but let's for example choose some place in Germany. I can, as I said, type the name of Paderborn here as an example, or enter its coordinates, and then I'm going to click on location search. So now Paderborn is chosen here in between, and it's a default location of Paderborn in the middle of the city. But yeah, you can also take a look at the address here and the exact latitude and longitude of the location. Now that the location is set correctly as what we want, let's go back to resources and then solar GHI, for example, global horizontal irradiance. So far there is nothing, no data is downloaded here. I need to click on this button, download from internet, and the data is downloaded. It means that this data is downloaded right now from HOMER server, HOMER energy server, and this is exactly for our location, which is in Paderborn. Okay, so this is global horizontal irradiance, average global horizontal irradiance, the amount of daily radiation in kilowatt hours per square meter per day. And for example, in January, this number is around 810 watt hours per square meter. And it goes higher, of course, as what we expect in summer, and then it goes down again in winter time. You can also see the amount of the exact amounts here in this table. You can change them as you want if you want, but this data is downloaded from, as I said, the server of HOMER Pro, and they also took this data from NASA Surface Meteorology and Solar Energy Database. And this, for example, specific data, global horizontal radiation, is monthly average values over 22-year period. So these are the average numbers of daily radiation data between 1983 and 2005. So it's over 22 years. So you can consider them as a good basic data. And you can also take a look at the latitude and longitude for the location that this data is taken from. Okay. Of course, in the middle of the city or at this location, 51.5 latitude and 8.5 longitude, there is no weather station, but of course NASA and other organizations can access the meteorological parameters with their satellites or other methods. So as I said, this data is taken from what NASA satellites are measuring for this point, and of course they are not 100% correct, but if we consider them as whole period of 22 years, yeah, you can say that, okay, this data is correct one, it's a good one. It's a good estimation for the whole period. I'm going to go to the next resource tab, solar DNI, direct normal irradiance data, which this part cannot be downloaded because there are no data sets for all data points on the globe. You can, if you have for your location, if you have any data, if you have taken the meteorological data for over a long period and you have the data on your own, you can import them here and then use it. But if not, you need to consider only solar GHI. Next one is wind parameter, wind energy, and the main parameter to consider the potential of wind energy is wind speed. So again, for this location, which is chosen in Paderborn, I'm going to click on wind here, download from internet, and then this is what is downloaded. It's this time it is the data is downloaded from NASA again, but wind speed is I mean, these numbers are at 50 meters above the surface of the earth, and their monthly average values over 10-year period. So they are not, they could be not as precise as solar GHI, which is taken for more than 22 years, but still 10 years is also not a bad number. It's long enough. And yeah, you can see that in the January we have the average wind speed of 6.78 meters per second, and then in February it's a bit lower, in March is higher, and during the summer it goes a bit lower, and then during the winter time it goes again back high. So we can say that I want to have you can change the anemometer height here. I guess this change doesn't make any difference in the data right now. So let's go to variation with height. You can also take a look at the variation of wind speed with height, and then you can also say that, okay, I want to calculate this variation with the logarithmic formula or the power law, which are two methods to calculate wind speed based on wind speed in another height. So the next one is the advanced parameter. You can say, you can also add variable k parameter here, and the other parameters which are important for wind energy assessment. And then next resource is the temperature data, again based on the location that we've chosen already. So I'm going to click on download from internet, and it is downloaded immediately. Again, this is average for over 22 years for Paderborn, and then these numbers are the average daily temperature and the average amounts depending on the month of the year. So of course in January and winter times it's really low. The average value is around 1 degree Celsius, and then in summertime the average temperature goes to around 18.35, for example, in August. So these are the basic data that we need to run our simulation. That was for the part of the introduction of the system.